Good evening, everyone, and welcome to Tropical Storm Erin edition of Florida Man Does Weather. Me and Caleb just wanted to give you guys a quick evening update on what we're looking at with Erin currently. So, what you're looking at right here with this bright, colorful map is this is a product from the University of Wisconsin. This is what they call the Sims Steering Project product. And what this is doing is this right here is showing your steering currents currently in the Atlantic Ocean. Okay. You might ask, well, what's important on this? All the models have it curving out to sea. Well, that's what we're going to break down today. If you look at this right here, you notice something very interesting. The steering currents bring the storm south, and then they bring the storm west. Okay. You see a lot of bright green and yellow on the map. That means the steering current is really strong. The forward speed is going to be really strong on the storm as it pushes through these regions. Now, important to note, when you have a developing hurricane that is moving at a high forward speed, that forward speed will create its own shear. Okay? We'll get back to that in a minute. One thing that we wanted to show that was very interesting is that something has stood out to me and Caleb this whole time, and that is the similarities at this point of this system with the wind currents, the wind patterns with Hurricane Irma from 2017. Now, granted, the maps don't look exactly the same, but you had two regions of high pressure. You had a trough to the north, and you had a weakness in between them. The models did suggest Irma would recurve. Irma confounded the models and continued west. Now, the thing that we have interesting here is, yes, we don't just have a trough; it's a cutoff low, but you have your two regions of high pressure. You have a weakness in between. You have the prevailing western flow underneath. We're just finding that very interesting at this point because so far, when you're running parallels, the development of this storm, the development of Irma, Irma was a hurricane a lot sooner, but the tracking is very, very similar. So that will bear watching over the next couple of days. Looking at this Sims product, this is your wind shear map. Now, currently, Caleb's going to give us an infrared view in just a moment. Erin is getting ripped to shreds. Reason why, Erin is currently under, if you see those yellows and oranges right underneath the little hurricane logo, Erin is underneath about 20 to 30 knots of shear in the southern portion of the storm. Now, you combine that with the storm's forward speed of 21 knots, 21 miles an hour, not 21 knots, 21 miles an hour. When you're looking at that forward speed with small storms, that creates its own shear. When a storm is moving at speeds above, I believe it's 18 miles an hour, it creates its own shear. So it's basically creating 21 miles an hour worth of shear on top of the shear that's already carrying into it. So Erin's got a lot going against it right now. That's also significant, though, because a weaker storm is going to be less prone to getting pulled north. Now, with that, I'm going to hand it off to Caleb. Caleb, go ahead and show us what you're looking at.
You have screen sharing disabled.
Well, try it again.
Uh, there we go. I did it. All right. So this is Erin. Very small, compact system right now. So as you can see, it's got persistent convection near the center. The center's a little bit off kilter right now because that wind shear is kind of got it structured like this. So you have like a surface low pressure here, and then your mid-level low is just a little bit off kilter because it's lagging behind it just a little bit.
Right.
But there's very good venting associated with Erin right now, and it's in diurnal maximum. So the ability for a developing storm to really pull energy and latent heat out of the water is very high right now. That's all diurnal maximum means. So the upper level venting is helping to basically keep that exhaust fan going for this developing storm, and it's helping to fight off a little bit of dry air and that wind shear that it's working with. But as we go out to our large scale water vapor satellite loop, you can see this big ridge is expanding. We're going to see another ridge kind of pop up over here. You've got that cutoff, and the cutoff was initially supposed to be the one to grab Erin. It was initially forecast to really stick around, and this is Invest 96L from well, last week. Yeah, this
Mhm.
was the one that had like a 40-50% chance of development, and it's a dead low at this point. It's being pulled into a mid-level circulation. So initially, some of the model runs were basically running this into here, amplifying this, and parking a cutoff low here, which would take Erin out to basically north of the Eastern Caribbean islands, and then it pulled hard north. Some were even doing it before that. It would do it like out here, northeast of the Eastern Caribbean islands. Recent model runs have shown that that is really not the case because we didn't really buy that a cutoff low would just sit there and park in August. This whole year has really been ridge dominant, and we just didn't really see a reason for that to end. I
Right.
mean, we've got the trough working in through the middle of the country, and now that is forecast to be the one that grabs Erin and whisks it away. So this was the 12Z Euro AI. We're just going to run through a couple of these. So 12Z Euro AI, you get Erin moving a little bit more southwest. And depending on how far southwest it moves, it's going to change your recurve path. So that's something to watch as well, because you get a storm take a further dip, your curve back becomes wider. And especially if it takes longer to strengthen, because your stronger hurricanes are they
Well,
just tend to pull north anyway because of Coriolis, but also they're more susceptible to trough pulls. There's a lot of different little dynamic intricacies with hurricanes and their strengths and stuff, and how it all interplays with its surrounding environment. But I'm trying to keep this one a little bit short, so we'll just go over this. So initially, your gap starts to form pretty quick. It's pretty evident. Right around here is where your weakness is with your steering high. And Erin sees it, pulls north in response to this trough, and your high pressure basically splitting in two. And then goodbye, Erin. Doesn't even hit Bermuda. And it was the same thing with the regular euro. Goodbye.
that's the
Where is
18.
it? Where? Oh, whoops. Let's see that. I was like, wait a minute, that's the cutoff. How do I move this guy out of the way? There we go. Grab the 12Z. So 12Z euro. Erin's over there. Gap. The cutoff is gone. Oh, look, a trough. Goodbye, Erin. Bermuda is spared. Everyone is spared. And then we've got other waves after this, but that's so far out, it's not even worth touching on yet, other than we're going to have more stuff to look at. But now, 18Z, the weakness is not there anymore. It's way less prevalent. So
Mhm.
this could continue to, be there, and it would extend and elongate that curve, potentially bringing some US impacts. Now, most of your ensemble models are not really showing that. I'll pull the GFS ensemble from 12Z, and we're just going to look at the individual members. And you'll see it's like 10% or less are pulling that kind of scenario. So right here, this is kind of the end of the cone for the forecast, and really the end of significant clustering with these ensemble members in your model agreement. So you have a main cluster that continues in recurves. And you have a secondary cluster that is a Florida and Southeast US cluster, just showing the potential for your recurve to be much broader, much slower to occur. It really just all depends on trough timing at this point. And we're still in that model range where things are going to run more on climatological averages and extrapolations of the data. Once you get over like 120, 150, and really, most of these curve events, this starts really happening at 156, 160. And then you really start to see like northward movement by 174. So we're still in kind of that model error from extrapolation time range. So it's just something that bears watching. We've been misled by some out to sea models before, and steering currents can change. They can change within just 2 days of what was modeled. You never know. Your thoughts, Josh?
Yeah, so I just wanted to point out too, and obviously this is not, this is not forecasting that anything's going to come
Mm.
to the United States or anything, but it is worth noting, okay? Like Caleb was saying, at hour 120, which is after 5 days, your model goes from running off of data, it shifts into a lower power mode to conserve electricity and energy and computing power. It goes into power conservation mode, and it switches to what it starts leaning heavily on what we call model output statistics. Model output statistics are what it starts reading on it starts making inferences based off of climatological data, things that happened at that point in time after that in similar events in the past. So the interesting thing to note is these troughs that form the weaknesses for air steadily keep occurring 150, 156 hours out, deep inside that lower power mode range of the models. The initial trough that was supposed to, the cutoff low that was supposed to pull Erin north, that was supposed to persist once it got
Just rolling
within
it
that
back.
one, once it got within the 120-hour range, like we just showed in the 500 millibar map a moment ago, it's gone. It pulls out. New one appears into the MOS range again, further out. So the thing that bears watching is this. Okay. You cannot be a good forecaster and just look at models and regurgitate models. You have to look at the current situation. Because when the models go into low power mode, they're going into climatology. They're not going into what is currently the pattern for that year. Well, me and Caleb have been discussing this extensively behind the scenes before we put together a video with you guys. And what we have noticed is your troughs are not surviving long once they exit the US coast. So it makes no sense all of a sudden for models to all of a sudden be insisting that a large, strong trough is going to persist and pull a hurricane out all of a sudden for the first time ever all season. Sure enough, the first trough, when it gets inside 120, it disappears. All of a sudden, lo and behold, you fall in the climatological range. Miraculously, another trough comes out of nowhere and creates another weakness. So, say all that to say this: there's still so much uncertainty. There's still so much error. The only thing we can really look at right now is the history of the pattern so far this year and compare it to analogs that we know. Now, I can say pretty confident. I have a feeling based off of what the models are showing, comparing what the models are showing to what we know with the troughs not persisting across the Atlantic without ejecting northeast, with our steering currents being predominantly westward, and then comparing it to analogs that we have. And right now, even though it was a much stronger storm at this point, a good analog in regards to steering, in my opinion, is Irma, because Irma had a similar setup, okay, in regards to the steering currents. Irma came a lot further west. So what I feel is, if anything, even if there's no U.S. impacts, I have a feeling, Caleb, that Irma, Erin is going to be coming
Easy to
a
do.
lot closer to the United States than these models suggest. Whether there's going to be mainland impacts, we don't know yet. But I do think that Erin will not be just circling out to sea. Erin will be making a much closer pass to the United States, possibly impacting at minimum the Bahamas.
Yeah, yeah. And some of those scenarios that we've really kept an eye on that bring it closer to the U.S., closer to the Bahamas, are ones where Aaron stays a little bit weaker for longer than anticipated. Some of the hurricane models, the hurricane specific ones, were really overly bullish this afternoon, and basically had Erin at hurricane strength tomorrow when that's not even really forecast. Like they had it at hurricane strength about 2 a.m. Uh, Wednesday morning. And strong hurricane at that. It was dipping into the 970s at that point. Now, if that were to happen, and it also had a larger system overall, larger systems are also more susceptible to
Right.
getting hit by troughs. They have more vorticity, so they're able to latch on to things a little bit easier. And that's just not the case with Erin. Erin's very, very compact. Let's just bring this up for fun, actually, just to show you the size of the wind quadrants. It's only 20 nautical miles and 30 nautical mile wind quadrants right now. This is a very, very small system. So sometimes these slip through the cracks. Now, are we saying this is, going to sneak by and do that? No, but we're saying it's like you lock up your house at night, but you leave a window open. Like there's still some opportunity there that can't just be discounted. All
Right.
right. It just bears watching. So thank you guys for watching this. We hope you guys enjoy your week. Yet again, we really don't have to worry about this. We'll have a very good idea of where this goes by next Friday, and it's not next Friday, but this Friday,
Yep.
and it's not even going to be near the U.S. at that point. So we'll keep everything updated. It's been real. Florida Man does weather out.